Good morning, everybody. Today we are going to do some more application problems with rational expressions. Before we start, I just want to clarify that our test on Chapter 7 is Friday this week, not Thursday. It is correct on your weekly summary. I think I misspoke during our Zoom yesterday. All right, so first type of problem we're going to look at is examples of inverse variation. You should have, I posted these problems so you could look at them if you wanted to print them out. But I tried to make it as big as I could here for you to see. All right, the first example says the time it takes to drive to Houston varies inversely with the speed. If it took Bobby 12 hours traveling at 80 miles per hour, how long would it take him traveling the same distance at 70 miles per hour? All right, so we need to set up an inverse variation problem. So we have time, t, varies inversely. So I'm going to use k because I don't know what that constant of variation is, with the speed or rate. So I have time equals k over r. All right, I want to solve for k here, so it took Bobby 12 hours. We don't know what that constant is, but we know that he was going 80 miles an hour. All right, I can solve this by multiplying both sides by 80. So I get k equals 960. So my direct variation problem says t equals 960 over r. Now we need to know how long it'll take him to travel if he was going 70 miles an hour. So now I need to fill in the rate of 70. If I get my calculator and if I divide that, I get 960 divided by 70. All right, so I'm going to round here to 13.7 hours. All right, we did some problems like this in the beginning of this chapter when we were doing inverse variation. Remember, they give you some sort of information so that you can find k. Once you have k, you write an inverse variation equation. All right, and then you use that equation to solve the problem. Our next example is a work rate problem like we had done in Zoom yesterday. All right, Fran could clean the garage in 3 hours, but it takes Angie 4 hours to do the same job. How long would it take them to clean the garage if they worked together? So remember that we said work rate is equal to the amount of work divided by the time. And we're assuming for the amount of work that for most of us, we are doing one job here. All right, so Fran's work rate would be one job cleaning the garage in 3 hours, so Fran's work rate is 1/3. Angie's work rate is 1/4, and together we don't know that work rate, so we're going to call that 1/x. All right, the equation you set up is Fran plus Angie equals together. So 1/3 plus 1/4 equals 1/x. Remember how we said we could solve a problem like this? One of the easiest ways to do it is to multiply by the LCD of all three denominators here. So 3, 4, and x, my LCD would be 12x. So I'm going to multiply this side by 12x, and I'm going to multiply this side by 12x. Okay? If I go ahead and distribute that 12x, I get 12x over 3 plus 12x over 4 equals 12x over x. Simplifying, I get 4x plus 3x equals 12, or 7x equals 12. Divide both sides by 7, x equals 12 over 7. If we go ahead and divide that out, we get approximately 1.7 hours that it would take them to clean the garage together. All right. Let's go on to our next type of problem, and that is your favorite kind. It is a wind and current problem. Okay? So our problem says Garth rows 5 miles per hour in Stillwater. It takes him as long to row 4 miles upstream as 16 miles downstream. How fast is the current? So one of the things that you need to remember in this type of problem is that the difference between the current and going upstream and downstream. So when you have a current, has anybody ever got on a canoe or a boat or a kayak or a paddleboard and you're not even paddling but you still are moving? That movement is the rate that the current is pushing you. So if you're going with the current is helping you. Has anyone ever been out on the ocean and you paddleboard down or you kayak down along the beach, and then you have to get back? And getting back is much harder because now you're going against the current. So even though you're paddling just as hard as you did this way, you're not getting as far because you're working against the current. So this is what is happening to Garth here. He's always rowing at the constant speed of 5 miles per hour. But when he goes upstream, he's got to fight that current. And when he goes downstream, the current is going with him. All right, so to do this problem, we are going to use the fact that distance equals rate times time. We can solve this is equivalent to, if I divide both sides by t, rate equals distance over time, or I could write time equals distance over rate. All right, in this problem, we know that in this case, the times are the same. It took him just as long to row 4 miles upstream as 16 miles downstream. So we're going to want to set up an equation that sets the two times equal to each other. All right, we're going to make a chart here with the distance, rate, and time. And we want to go upstream and downstream. All right, and this is a D for distance. All right, he is traveling 4 miles upstream and 16 miles downstream. All right, let's think about the rate. All right, when we think about the rate, what happens when I go upstream? It is my rate minus the rate of the current. And when you go downstream, you're going to have your rate plus the rate of the current. All right, in this case, we do not know how fast the current is, so we need to give that a variable. So in this case, we're going to call it C. So going upstream, my rate is 5 miles per hour, but I'm going against the current, so I have to subtract off C. Going downstream, I'm still rowing 5 miles an hour. My rate doesn't change, but this time I'm also getting helped by that current, so I want to add C. All right, so for my time column, time is equal to distance over rate. So here I get 4 over 5 minus C. Here I get 16 over 5 plus C. All right, using this piece of information right here that says it takes me as long, or these times are equal. So 4 over 5 minus C is equal to 16 over 5 plus C. All right, once you have that set up, we are now just solving a proportion. So I can go ahead and use my cross multiplication. So I have 16 times 5 minus C equals 4 times 5 plus C. 16 times 5 is 80. Minus 16C equals 20 plus 4C. Going to add 16C to both sides. I'm going to subtract 20 from both sides. So I get 60 equals 20C. Divide both sides by 20. Oh, you really can't see that. I'm going to have to do a little bit of moving here. So I get 60 equals 20C, divide both sides by 20, I get C equals 3. All right, so the rate of my current is 3 miles per hour. All right, you'll see this kind of problem applied with planes. Planes can have tailwinds, and a tailwind is a wind. So they have tailwinds and headwinds. Tailwinds is a wind that comes from the tail of the plane. So a tailwind helps you. A headwind is coming up, the head of the plane is going into the wind, so that would make you slow down. So a tailwind will increase your increases your net speed, and a headwind decreases your net speed. We have a little glare there, so hopefully you can read that. All right, so a plane flies 450 miles with the wind. With the wind means that it's helping, it's a tailwind. And 300 miles against the wind. Flying against the wind is a headwind. It decreases my speed in the same length of time. So again, the thing that we know that is equal here is in the same length of time. If the speed of the wind is 29, what is the speed of the plane in still air? So still air means if there was no wind pushing you against you or helping you, how would your plane be flying? What would that speed be? All right, so in this case, our problem's a little different. We know the current. We do not know the plane speed. All right, so let's let S, it's a P, use P for the speed of the plane. Okay, so again, I'm going to make my table. It's going to be similar to my last table because I know that my last column here, I want to have time because I know the times are equal. So this is with the wind, this is going to be against the wind. All right, 450 miles with the wind and 300 miles against the wind. All right, we know that with the wind, it increases my net speed, so I don't know what my speed is, P, but I know I'm going to add 29 onto it because 29 is the speed of the wind. Going against the wind, I'm going to take my speed and I have to subtract off 29 miles per hour because the wind is pushing me. All right, so here using that time equals distance over rate, I get 450 over P plus 29 and 300 over P minus 29. And I'm given that these take the same amount of time. Okay, I get the same time. All right, so now let's solve. So I'm going to set this equal to each other. 450 over P plus 29 equals 300 over P minus 29. All right, I'm going to cross multiply. So I get 450 times P minus 29 equals 300 times P plus 29. Multiplying that out, I get 450P minus, I don't know if I have, I'm going to have to do that math here. 450 times 29, 13,050 equals 300P plus 8,700. All right, so I'm going to subtract 300P. And I'm going to add 13,050 to both sides. Okay, so now I'm going to get 150P equals 21,750. I take that divided by 150. Just do it one more time to make sure I did it right. I get P equals 145 miles per hour. All right, so the speed of the plane is, if you can, I'm going to write that up higher so that you can see that. P equals 145 miles per hour. All right, hopefully these videos will help you do your classwork problems, your homework problems, I mean. You have the option of finding a friend who wants to do it with you, FaceTime, making your own Zoom, Google Hangouts, whatever you want to do. If you do work with a friend, please put your name on it as to who you worked with so that I know that. Thank you.